monocytes are very, very distinct, about as different as they can be. And this makes sense based on the cytokines, the different set of cytokines that T cells express. We know that cell contact and soluble factors are absolutely required for this differentiation and subsequent polarization. And what we believe we've identified is really a massive positive feedback loop where T cells initiate responsiveness and then DCs continue. And kind of to give an example of this, I go back to the initial skin model. And let's say you have a cut or you have some type of insult and your pathogen comes in. Right? And your pathogen is going to start to divide. And your steady-state dendritic cells come and acquire the pathogen, the antigen, and they transport it to the draining lymph nodes. Now we know from studies that this is not going to be sufficient to clear infection, so you need the formation of inflammatory dendritic cells. And in these situations, the monocytes come up, they can also acquire and process the antigen, and they wait for signals to tell them to become a dendritic cell or not. And shown here, if it's a Th2 cell, which is not specific for this pathogen, you're just not going to get the memory type responses and it's going to go on its way. But if you're the Th1 cell or the T cell responsible for the antigen specificity of the pathogen, then that Th1 cell can come, interact with antigen-specific or antigen-driven manner, cell contact, and elicit the formation of DCTH1. And we know from our flu studies that this differentiation seems to be serial where one T cell can drive the formation of several dendritic cells. Once these dendritic cells are formed, we then traffic back to the lymphatics. And then the lymph nodes, they mediate the amplification of Th1 cell responses, shown here. And this is great during infection. Obviously, if it's dysregulated in psoriasis or atopic dermatitis, it's detrimental. And this is what we believe is happening in both diseases. Oh, in terms of what's next, we go ahead and we look at our pipeline. We're obviously going to do further in vivo investigation. And Matt Davidson is really taking the lead on this project with the help of Bungo and the psoriasis model. We're also looking at how do we stop inflammatory dendritic cell formation. I'm going to stop it right here. Just don't allow them to form for therapeutic purposes. And this is being done with Megan and Ignacio. Lastly, we were looking for the targeted depletion of these inflammatory dendritic cells. And we're using antibody-based methods conjugated to a toxin to bind these cells and destroy them such that you can prevent subsequent inflammation. This is being led by Josh. So I have a lot of collaborators. Kind of the most important one in terms of this work is really Mike Wong. He was beside me in the mines all night, all day, and we rinsed and repeated this for a very long time. So Mike, there you are. Thank you very much for your help. Also, the Engelman lab was really indispensable for this, of course. Matt, Megan, Josh, Lorna for cell sorting, for being like a second mom, Claudia for doing the same things. It's really a deep bench in the Engelman lab that contributed to this. I also had several summer students, Tiffany, very, very helpful, and Joey, our gem, also extremely helpful in this process. In terms of getting the blood, I was at the blood center, so I wanted to make sure I utilized those resources, and Karen was absolutely critical for giving me blood at all times of the night, and I really appreciate that. For the psoriasis and atopic dermatitis work, obviously Peter's lab, Bungo, and other collaborators in the psoriasis realm. And work that I didn't talk about, there's a whole other body of data that we're forming in organ transplantation and looking at the role of monocytes and tissue rejection and everything else. And for this, it was Pravesh, Lili, and Silka that was very incremental in these studies. I also want to thank my thesis committee for being here and your guidance. And Ed, I want to make sure I get my thanks out to you. Ed's one of those bosses who's really incredible because he gives you a very high degree of independence. And when you're a first-year student, this sucks. You run around, you have no idea what you're doing. The independence is tough. But as you mature, you really realize and you appreciate how much more prepared you are to go out into the real world when you're given this independence. And I really appreciated that. So thank you. And I want to make sure Megan at the same time to give her the shout out. Kind of when I was running around, I was like, I don't know what I'm doing. She was in the lab, she was very helpful in kind of directing me to set up the appropriate controls and make sure that I'm running proper experiments.